talk about what you discovered yesterday. Okay, there was a pattern with our symmetry. Okay, there was a pattern with our symmetry. Did anybody notice a pattern with symmetry? Mm-hmm. 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 If we have a function in terms of sine, then we have symmetry with respect to our vertical axis. Why would that make sense? Sine is the like coordinate on the unit circle, right? So if we have a function in terms of sine, we have symmetry about the vertical axis. If we have a function in terms of cosine, we have symmetry with respect to the polar axis or the horizontal axis. Okay? We're not going to call them the x and y axis in polar coordinates because we don't have x and y in polar coordinates. Okay? So we can say vertical and horizontal. Horizontal is the polar axis. Okay? So no matter what type of function you have, if you see a cosine, you know you're going to have symmetry along the horizontal axis, sine along the vertical axis. Okay? Today we are going to talk about circles and the rose curve, the flowers that you graphed. On Tuesday, because we don't have school Monday, kind of forgot about that. On Tuesday, we are going to graph those limacons, those four funky shapes. They look kind of like warped circles, basically. That's what we're going to talk about on Tuesday. Okay? So first, let's talk about circles. Okay? There are three different ways to make a circle. One way is just R equals A. What does this circle look like? Where's the center? The center's at the origin. Okay, when we're talking about the polar coordinates, instead of the origin, we call it the pole. This is the pole. Okay. So we have a circle with center at the pole, and what is the radius of this circle? A. Whatever that value is, okay, that's our radius, right? What about if we have a coefficient in front of cosine theta? Where does our circle go? Okay, it goes to the right or left of the pole. So we're going to say that this is a positive A, which means it would go to the right, right? How far, like A corresponds with what on this picture? Okay, how far it stretches out, so in the circle it's representing the diameter. Okay, if it's a negative A, it's going to go where? It's going to go left. That's what you figured out yesterday in section 1. Okay. What about if we have R equals A sine theta? Where's our circle going to go? It's going to be up or above or below the pole. So if A is positive, we'd be above the pole, but we still go through the pole. It touches the pole. Still not great. Okay, and A represents what? Okay, the diameter, how far it stretches. If I asked you for the radius of one of these two circles, what would it be? It would have to be half of A. Right. Good. So, a part of your worksheet, I will ask you to graph a circle, okay? And this is what your worksheet is going to look like anytime you graph an equation for me, okay? I'm going to ask you for what kind of shape it's going to be, the max R value, so what's the maximum distance from the pole, how many zeros, what are the zeros, and then you're going to list some points for me, okay? When I say zeros, what do you think that's going to mean?
Points where it touches the horizontal and vertical axis.
I wish that were true, okay? It is no longer about the axes, it's about the pole. So anytime you see zeros, that means where does it touch the pole, okay? And the pole is just what we think of as the origin, okay? So that is going to signify a zero because R is 0 at the pole. That's why they're called zeros in polar coordinates, okay? So let's talk about this equation right here. R equals -5 sine theta. What kind of shape is it? It is a circle. It's a circle where in relation to the pole? South. Okay. And it's going to stretch how far? Okay. There is our circle. Now, what is our max R value? What's the furthest away this circle gets from the pole? Okay, and we can just say 5. Okay, we don't have to say -5 because we're talking about a distance here. So this circle is 5 away from the pole. Okay. Let's talk about significant points here. Okay. If theta is 0, what does that make R? 0. If theta is pi over 2, what does that make R? Seriously, what's the sign of pi over 2? What's the sign of pi over 2? 1. So R would be -5, which is why here at pi over 2, we're backwards 5, right here. Ooh, that makes sense, doesn't it? Yeah. What about at pi? What is, at pi, what is R? Oh my goodness.
0.
Thank you. Okay, so we start at 0, 0. We go to pi over 2, -5 pi over 2, and we're back to 0 pi. How many times did we just go through the pole? Twice. Where did we go through the pole? At 0 and at pi. Okay. Now we figured out our zeros by looking at this chart. Algebraically, how could we do it? Wherever R equals 0, so we could say when does -5 sine of theta equal 0? Or when does sine of theta equal 0? Okay, and we could say 0 and pi. Okay, now I will tell you, some of our graphs, it will take from 0 to pi to draw the graph. Some of our curves will take from 0 to 2 pi to draw the entire graph. For a circle, it only takes from 0 to pi to draw it. Okay, so we started at the pole when theta was 0. We ended back there when theta was pi. Okay, it only took from 0 to pi to draw that circle. Okay, you know how yesterday when you put something into your calculator and you could watch your graph being drawn? Okay, as you watch your graph being drawn, they're plugging in the angles 0 and then the next angle and the next angle all the way up until pi or 2 pi. Okay, so you could actually see that graph being drawn by what angle they're plugging in. Okay. Questions about the circle? Okay. Circle should be the easy one, right? Does anyone have questions about the zeros? Okay, the number of zeros, I'm just asking for, hey, how many times does it go through the pole? What are those times? What theta values are those times? Okay. For a circle, you're either going to have 2 zeros. If it is a cosine circle, you're only going to have 1 zero. Okay. Would you like to look at a cosine circle or not? Yes. Okay. R equals 3 cosine theta. Where would that circle be? On the right side. Thank you. And it would stretch 3, right? Okay. What's the max R value? 3. Okay. Let's talk about our significant points. When theta is 0, what is R? What's the cosine of 0? 1. So R would be 3, which means we are beginning here at 0, 3. At pi over 2? 0. And at pi. What? Careful. What's the cosine of pi? -1. So here at pi, we're at -3. Okay, so there forms our circle. How many times did we go through the pole to draw this circle? We went through it once. Alright? So we only have 1 0 at pi over 2.
So what would be the max R value for this one?
3. It's really going to be whatever that A value is. Alright, let's talk about roses. Okay, we need to spend some time with roses. There are 2 different types of equations, and this is where your note sheet is going to come in handy, right? A cosine of, I guess on your sheet is B theta. A cosine of n theta. Okay? What does A determine? What? Oh, I can't spell. Oh my goodness. That looked awkward. Okay. A determines the length of the petals. Okay. We're also going to call that our max R value. That's going to be our greatest distance away from the pole. Okay. What does N determine?
The number of petals.
N determines the number of petals. Now, we kind of have some weird rules here, don't we? Okay. If N is odd, how many petals do we have? If N is even, how many petals do we have?
2.
Okay. Now, everything, dealing with A and N, okay, they're going to be the same whether we have sine or cosine. But what's going to be the difference with our rose curves if we have a sine versus a cosine? Okay, the symmetry is going to be different. Our cosine rose curves are going to be symmetric about the horizontal axis. Our sine rose curves are going to be symmetric about the vertical x-axis. Now let me ask you something. What is the cosine of 0? What's the cosine of 0? 1. The cosine of 0 is 1. So anytime we plug 0 into a rose curve that looks like this, we're going to get A times 1. So what that means is that this rose curve is going to begin on the horizontal axis, which is where we have our symmetry. Okay. Now what is the sine of 0? 0. Okay, which means if we plug 0 into an equation that looks like this over here, we get r is 0. So what that means is that this rose curve is going to begin at the pole. Okay, and that's going to be the difference as far as us beginning to graph these. Okay. Okay, so we are going to do 3 graphs for sure today. All right. I'm going to skip around, I think, in the order that I was going to do this. We're going to do this cosine one first. Okay. We are going to do r equals 5 cosine of 3 theta. Now, how do we know that this is a rose curve? Okay, this theta has a coefficient, right? As opposed to a circle just has theta. Now, how many petals is this rose curve going to have?
3.
Okay, anytime you identify a rose curve, you must identify how many petals it has. Our max R value is the same thing as in a rose curve. How long are the petals?
5.
They are 5. Okay, we are going to do the number of zeros and zeros last. We're actually going to plot our curve and then worry about the rest. Okay, now significant points, I am not going to make you draw every single one. Okay, but you need at least a couple to get your graph going. So you should always have a significant point of theta being 0. Okay, we need to know where to begin. When theta is 0, what is r? 5. Okay? So, that is our max R value. So we know we have a petal right there, don't we? Okay? Now, you graphed a bunch of these yesterday. Are our petals evenly spaced? They are. So we have 3 petals that need to fit in this 2 pi rotation. How far apart do our petals need to be? Exactly. Okay? Our petals. Okay? They need to fit in this 2 pi rotation, and there are 3 of them. So if we take 2 pi and divide it by the number of petals, that's how far apart they need to be. It's really as simple as that. If you need to use degrees to help you, I don't care, that's fine. All right? But we have a petal there. 2 pi over 3 is here. 2 pi over 3 more would be right. What? No, wouldn't it be here? Okay. So now we can draw our curve. Okay, we know where our petals are going to be. Now, pay attention to how many times I cross the pole as we draw this, we're going to figure out how many zeros we have. Okay, you ready? 1, 2, 3. We went through the poll 3 times, which means we are going to have 3 zeros. What? Okay. Okay. So now, we need to figure out where these zeros are. Okay? How are we going to figure out where these zeros are? Plug in 0 for R. Okay? So, really we need to know where 0 equals the cosine of 3 theta. Now remember, the cosine equals 0 an infinite number of times. But how many of those do we need to list? 3, because we need 3 zeros. So, remember our angle is 3 theta. So 3 theta equals, when's the first time cosine is 0? Where's cosine 0? Pi over 2. And when's the next time? 3 pi over 2. But we need 3 zeros, so I need one more time. When's the next time that would be 0? So we're at pi over 2, 3 pi over 2. Yes? 5 pi over 2.
So you don't want to go for negatives.
No, we're going to go in the positive direction. Okay? So here are the first 3 times in the positive direction. Cosine is 0. Well, that's what 3 theta equals. So what do we have to do to get our zeros? So we have pi over 6, pi over 2, and 5 pi over 6. Okay, so I would want to see that at pi over 6 we have an R of 0, and that would be enough significant points for me. Okay, because I will look at where you place your petals. Okay, questions? Okay. Next example. Okay, let me ask you. I'll let you be in charge. Would you like to look at another cosine one, or would you like to look at a sine curve? What did you say?
I just want to see where this one.
Yeah, we're going to do 3 total. Okay? So how do we know this is a rose curve? Okay, theta has a coefficient. This is a rose with how many petals?
4.
4, because our coefficient of theta is even, so we have to double it. So there's 4 petals. Okay? What is the max R value? 4, because that's what this coefficient is right here. Okay, so where does this curve begin? When theta is 0, what is R?
0.
We begin at the pole. Okay? Which means we do not know where to place our first petal, do we? How are we going to determine where we place our first petal? Any ideas? We do, but how do we know where that's going to be? kind of on the right track. Okay? If we need to know where our petal is, what would R be?
The next step.
Okay, so we need to know when is the first time R is 4, right? Which really means when is the sign going to be 1? Does that make sense? We need to know where our petal is going to be 4 away, because that means that's where our petal is. That's our max R. All right? So, I divided the 4. When is the sign equal to 1? Well, when is the first time sign is 1? Okay, so that means this 2 theta needs to be pi over 2, which means our first petal is where? Our first petal is going to be at pi over 4. Okay? That's the hard part. Okay? We have our first petal. As long as we have our first petal, determining the rest, not a problem. Because we know how, we know they're all going to be evenly spaced. So how do we figure out how far apart they are?
2 pi divided by 4.
Okay, there's 2 pi that these petals need to fit into, and there are 4 petals. So they really need to be pi over 2 apart, which is the same thing as 90 degrees if you need to think about that. So we have a petal here, pi over 2 later here, pi over 2 later here.
We're gonna have to show you that math, or can you just look at that and be able to tell?
Which math down here?
Yeah.
You can do this in your head. I'm going to look at where your petals are. Okay? And even if you do this up here in your head, that's fine too. Okay? So now, we begin at the poles, right? I'm going to draw this. Count with me how many times we hit the pole.
2, 3, 4, 5.
Since we started and ended at the pole, we have 5 zeros that we need to find. Okay. How do we find zeros? Okay. To find our zeros, we need to plug 0 in for R. Which really means 0 equals the sine of 2 theta. Okay. Which means 2 theta is our angle needs to equal, okay, we have 5 zeros we need to find, so we need to list the first 5 times sine is 0. Where's the first?
0.
Next.
5.
Next. 2 pi. Next. 3 pi. Next. 4 pi. Now I have 1, 2, 3, 4, 5 numbers listed. Then what do we need to do? Divide by 2. So our zeros are at 0. Pi over 2. 2 pi over 2. 3 pi over 2. And 4 pi over 2. Alright. Questions here? Okay. Anytime you have a sine rose curve, you start at the pole, which means you're going to need to figure out where that first petal is. Okay, so that's going to be one extra step as opposed to the cosine curves. We know where those petals begin. Okay. Also, since our sine curves begin at the pole, we're going to have an extra 0. Notice how we had 4 petals but 5 zeros? That's because we started at the pole and had to end there. Yes?
For up there in the blue, why did you put a 4 in for R?
We needed to know where our first petal was, and we know that our petals are 4 away.
But you're
Right, at
so
its
it's not
max.
far away, it isn't.
Yeah. Mhm.
Will it usually equal one?
That was why we did it, yes. It will always equal 1. So if that's the case, if you want to think of, we know it's going to equal 1, where does this equal pi over 2? That's fine too. Okay. All right, let's get another one. Okay. What do we have?
Rose curves.
A rose curve with 4 petals. And how long are those petals? They are length 3. Okay. Let's talk about where our rose curve begins. When we plug in 0, R is, oh, that makes it nice, doesn't it? Okay. When you graph, your first step always needs to be to plug in 0 for theta, then you can go from there. Since we know where our first petal is, we can place the rest. How far apart are our petals going to be? They're going to be 90 degrees apart. There's 4 petals that we need to fit in this 2 pi rotation, so they're going to be pi over 2 or 90 degrees apart. So one's going to be here. Where's the next one going to be? Next one. 5, and then 3 pi over 2. Okay. So now let's trace our curve. You tell me how many times we cross the pole. Are you ready? We begin here, correct? How many times do we cross it? So there are 4 zeros that we need to find. How do we find those zeros? Plug in 0. Okay, I'm going to let you find me the zeros. Do you know how many there needs to be? We've set up the equation. You do the rest. Do you have zeros for us?
Not
Dylan, what do you have so far?
You plug in 0 for r, right?
Yep.
And then you try to find where cosine 0 then?
So that would be what 2 theta is.
2 theta is pi over 2 and 3 pi over 2.
Good. But we need 4 of them, right?
Yeah.
So where would the next 2 places be?
It's like 5 pi over 2.
Mm-hmm.
7 pi over 2.
Good. Then what would we have to do to find theta?
About that 2.
Good. So your 0 should be at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Questions on those zeros? Okay. Remember how I said some of these graphs will take 0 to pi to draw them. Some of them will take 0 to 2 pi to draw them. I'm really not concerned if you pick up on that or not, as long as you can get me the graphs. But if that's something that you're interested in, if there is an odd number of petals, it only takes from 0 to pi to get it drawn in its entirety. But if there's an even number of petals, we have to go all the way from 0 to 2 pi to get those petals drawn. Okay? So if that's a pattern that you want to pick up on, great. If you don't remember it, it's not going to affect getting these graphs drawn.
When you draw these graphs, are you gonna want us to have how many significant points?
I'm going to want 2 significant points. So in this case, I would want you to go in here and say, okay, when theta is pi over 4, r is 0. So that you should have 2 significant points. One of them is going to be a 0, one of them is going to be a petal length. And then I'm just going to look at your graph and make sure your petals are spaced apart. Okay? I'm not going to make you go through and list all of those points. Okay? I really just care about what this looks like. Okay, so I will give you an option. I can either go through one more curve with a sign, or I can give you your worksheet and we can kind of work together on those. Ready for your worksheet? Okay.